Okay, now we're going to look at solving polynomial inequations. So we've looked at equations, now we're going to look at inequations. Well, we've looked at linear equations, fairly straightforward. What about quadratic inequations? So something like x plus 2 times x minus 3 is greater than or equal to 0. Okay, so there's a couple ways of looking at this. So we could look at this graphically or in what's called a factor table. Okay, so graphically, we look at this function. So on the left side, if we graphed it, it has an x-intercept at -2, and it has an x-intercept at 3. And it's a parabola that opens up like that. And we're looking at the result of this product, which is the y value of this parabola. So when is it greater than or equal to 0? Well, it's greater than or equal to 0 over here, including that point, and over here, including that. Okay, so we can write the solution set now as x is less than or equal to -2, x is greater than or equal to 3. Okay, the table method would look like this. This will be useful as they get more complex and when we get into rational functions. So x plus 2, write down the factors here, x minus 3, okay? And then what we do is we notice that this could be 0 at a value, this can also be 0 at a value, so I'm going to put 2 lines straight down, okay? And up here above these lines, I'm going to put the breakpoints of these. So the points where are the values of x that make it change from positive to negative or negative to positive. So at this one, it's going to change at -2. This one's going to change at 3. I'm going to put them in order, so -2 and 3. If these happen to be listed in a different order, this can't be in a different order. This is representing the number line, so -2 comes before 3. Okay, 0 would be in here somewhere. Now we can fill in the intervals in here. So this is -infinity to -2, and this is -2 to 3, and this is 3 to infinity. But we'll expect that that's understood, and we'll write the answers down at the end. Now because this says greater than or equal to, what I'm doing here is I'm going to circle the -2 and the 3 because it says equal to 0. If that was just greater than, I wouldn't circle those because I don't want them part of my solution. So I'm circling it because that's what I want. I want to make sure those are in my solution set. Okay? So now what we do is this changes signs at -2. So I'm going to put a little blip there. And this changes signs at 3. So I'm going to put another blip there. This is like an equation of a line. Y equals x plus 2. X plus 2 has a slope of 1, it's positive, so it goes from negative to positive. It goes like this. So you know it's going to be negative on this side, positive over here. This one, negative, positive. Now the product of these two is the left side. So I'm just going to put an x there for multiplying these two. When I multiply these two, I'm worried about the signs because I want to know when it's greater than 0 or less than 0 or equal to. So negative times negative is a positive. Positive times negative, negative, and positive times positive, positive. Now this represents these two multiplied. It's positive in this interval and this interval. So I'm going to circle those because that's greater than 0. I've circled that, so those are my solution sets. Negative infinity to -2, including -2. Negative infinity to -2, including -2. Or 3 to infinity, including 3, just like I have over here. Okay, so x is contained in that. Now that's for a quadratic. What if we had something that was a little more complex, like a cubic? Now remember, also this is factored. You'll probably get one that isn't factored, and you'll have to factor it first. Or you'll need to use a quadratic formula to figure it out. Okay? So what if you had x plus 2 x minus 3, x plus 1, and say that was, again, greater than or equal to 0. You could graph this. Okay, we know what the graph looks like. It's pretty easy. So we've got -2, -1, so -2, -1, and 3 are the x-intercepts. Positive leading coefficient, so it comes down like this, goes up, comes down like this. And when is it greater than 0? Well, it's greater than 0 from here over and between these 2 points. Okay. The table method will look like this. Write the factors: x plus 2, x minus 3, x plus 1. It's going to be 3 points where it breaks, so the lowest is going to be -2, -1, and 3. This changes signs at 2. Oh, I got to circle these because it's equal to. Let's change signs there. This changes signs here. And this one changes signs at -1. Negatives to the left side because these are all positive x. Positive to the right sides. Multiply them, you get a negative, positive, negative, positive. So there are my 2 intervals. Between -2 and -1, like I've got here, and greater than 3. Therefore, x is contained in -2 to -1, or 3 to infinity. Okay. Now, if we have an equation like this one, say x plus 3 squared, x minus 2, and x plus 5, let's say greater than or equal to 0. Well, then if we graph this, we're going to see that the graph it's got x-intercept at -5, and at -3, and at 2. Okay, and because it's squared at -3, it's just going to touch there. So it's going to come down through here, touch at -3, come back, and go back up like that. Okay. So when we're looking for when it's greater than or equal to 0, we're looking at when x is greater than or equal to 2, less than or equal to -5, and equal to -3, because it touches there, that's equal to 0. When we look at the factor table, well, we've got something like this: x plus 3 squared, x minus 2, x plus 5. Okay. Breakpoints are -5, -3, and 2. Always lowest to highest, because this represents the number line. And these blanks here are intervals in between. So this is going to change signs possibly at -3, but it's squared, so it's always going to be positive. Okay, when you square a number, it's always positive. This one changes signs there, and this one changes signs there. So negative on the left, because it's a line going with positive slope, positive on the right. Okay, and then the product of all those, 2 negatives make a positive, 1 negative, 1 negative, and then positive. When is this greater than or equal to 0? Here. Oh, and we've got to circle all of these because we have greater than or equal to, so these ones show when it's equal to 0, and here. So now we can do the intervals. So less than or equal to -5. Okay. So negative infinity to -5 inclusive. x equals -3, and 2 to infinity is our set for this one. Okay, so that's what happens when you have a squared piece. You might get a single number in there. Okay, so if you have a cubed one, it's going to go through with a twist, but it's going to be just like a linear. And this is basically what you're going to be doing with polynomial inequations.